This is the retake video for pre-calculus for the test of sections 4.1 to 4.3 with the introduction to trig. And like it says, a reminder, if you did not have all the homework for sections 4.1 through 4.3 completed and submitted before we took the test, you are ineligible for the retake. So work on the current material, try to do better from there. Number one, if you're doing the retake, you want to watch this video, you want to take notes on everything. You want to make sure that you have that down on paper because you're going to have to show that to me to verify that you actually watched the video and went through everything. Number two, you need to go back in your notes and you need to highlight the problems that are similar to the test problems so you can see they did come from concepts that were right in the notes. Number three, redo the review assignment. Now this time, make sure that you take some extra care, take your time, make sure you understand the concepts. And when you get to a problem that you know that you, did wrong the first time through the test, stop and give it a little more time and think about it and study it. And then number four, you're going to make a video and you're going to send that video to me by March 10th at 2:45 p.m. And it's going to show me everything from steps 1, 2, and 3 above. No exceptions. In that video, flip through all of the above work and I'll check to see that everything has been completed. And notice that that's the day before the retakes of the test are due. And again, my hours are from 7 to 2:45, so you need to make sure that you get those in during the school day. And then we have the deadline for the retake, which is March 11th at 1:45 p.m., no exceptions. And I'm definitely going to stop. Last semester, if some people were late with things, I said, okay, well, we'll make it work here. I'm not going to do that anymore. You know, this is something we have to get used to. It's unfortunately our new normal for right now. And you have to get a planner, you have to get a calendar, you have to write these dates down. You are so fortunate to be able to do retakes. The students at Pine Tech are not allowed retakes. So this is an over and above thing that we're doing right here, and you need to take advantage of it, and you need to make sure that you follow the guidelines. So now, what we had for the test. All right, number one said assume that theta is an acute angle in a right triangle satisfying the given conditions. So the first thing you'd want to do is draw your triangle. And it says evaluate the indicated trigonometric function. Well, you have to figure out which of those angles you want to use as theta, and I marked this little angle right here. And then you have to know what cosecant is, since cosecant of theta is 15/2. Cosecant is what you get when you flip sine. So it's going to be hypotenuse over opposite. So you make sure that you put the 15 in the position for the hypotenuse, and you put the 2 in the position for the opposite. And then you're going to have to use the Pythagorean theorem to figure out what the other side length is. And this was the non-calculator part. We didn't give you any numbers. We didn't assume that you have already, memorized really over the years as your perfect squares. So you get the square root of 221, and then you have to find the cosine. And cosine is adjacent over hypotenuse, so that's the square root of 221 over 15. Number two says, give the exact value. So when you see cotangent of pi over 6, right away I'm hoping that you're saying, okay, 180 divided by 6 is 30. They're really asking me for the cotangent of 30 degrees. You sing the little 30, 60, 90 song and you get it down here. Now, I mentioned that because there were some people that had the 1 and the square root of 3 turned around in this one. So again, the 1 is always opposite the 30-degree angle. And the square root of 3 is always opposite the 60-degree angle. And that makes sense because the bigger the angle, the bigger the side opposite. And then cotangent, tangent is opposite over adjacent, so you have to flip it, and that's going to be adjacent over opposite. For our 30-degree angle, the adjacent is the square root of 3, and the opposite is the 1. So that's the square root of 3 over 1, which is the square root of 3. For number 3, solve the equation. They've given us the cotangent. And then they're telling us that the angle has to be between 0 and pi over 2. That means first quadrant. So you look at that and hopefully you're saying, I need a triangle with 1 and the square root of 3 as part of its sides. Hey, I just did that in number 2. That's a 30, 60, 90. So you redraw your 30, 60, 90 and you think of cotangent, again, adjacent over opposite. And you put those on, and you use theta to do that, wherever your theta would end up being. So for the cotangent, the adjacent over the opposite, to be 1 over the square root of 3, this side would have to be the adjacent, and this would have to be the opposite, which means it's the 60-degree angle that we're talking about. But when it says the angle has to be between 0 and pi over 2, that means you need an answer in radians. So you have to change that 60 degrees into pi over 3, use your thinking backwards again, and get that pi over 3 piece. Number 4 says, find the measure of two angles, one positive and one negative, that are coterminal with a given angle. And the angle is 7 pi over 5. And we know that we have to go 2 pi, add and subtract multiples of 2 pi to make this happen. And we're going to need a common denominator of 5. So we'd have to multiply the numerator and the denominator by 5, which would make it 10 pi over 5, which is still 2 pi. And we just add and subtract 10 pi over 5 to the 7 pi over 5 to get our two coterminal angles. Number 5 says, find the trigonometric function value for the angle shown. So the first thing you'd want to do is come down here and realize that if this ordered pair is 7, 6, that means your x is 7 and your y value is 6. And then you could quickly use the Pythagorean theorem to figure out that your hypotenuse is going to be the square root of 85. And now what they want us to find is the cosecant. And cosecant is what you get when you flip sine. So it's going to be hypotenuse over opposite. So our theta is right here. That angle formed is the central angle, and that's theta. And so if we need hypotenuse over opposite, it will be the square root of 85 over 6. So far, I hope if you're checking your work, the distance learners, because you probably still have that sitting in front of you, you're able to see what the mistakes were that you made and know what you need to focus on in the future. And then the next one says, point P is on the terminal side of theta. Evaluate the indicated trigonometric function for theta if the function is undefined, write undefined. And they give us the point -8, 5. So you absolutely want to get that on a coordinate plane and take a look at it. And again, if you're supposed to find sine of theta, you know you're going to need the hypotenuse. So you quickly use the Pythagorean theorem here to figure out what you have for the hypotenuse. And your central angle is theta right here. And we want the sine of theta. And sine is opposite over hypotenuse. So that will be 5 over the square root of 89. And of course, we have to rationalize the denominator. I've talked about that in a lot of the lessons because these things are historic. They have been around so long that we want those perfect answers, those exact answers. Well, number 7 says, choose the point on the terminal side of theta. And all they give us is that theta is 150 degrees. So you definitely draw. You're going to notice for almost all of these, you did drawings. And the people that struggled on this test did not do drawings. You have to draw. It's the best way. Trig is so visual. So we've got 150 degrees, and we go across 150 degrees, and we realize, well, that's going to leave us 30 for our reference angle. So if that's 30 degrees, the side opposite is a 1, the side adjacent is negative square root of 3, because this is in quadrant 2, and then our hypotenuse is 2. And we need to choose a point that would be on the terminal side. Well, we just said if you go left, negative square root of 3, and up 1, you're at a point that's on that terminal side. So that would be C. Next up, evaluate without using a calculator by using ratios in a reference triangle. That tells us we're talking about 30, 60, or 45 as we look at these. So 8 says cotangent of 300. Again, you draw it and you realize, oh, my reference angle for my reference triangle is 60 degrees. Let me put my labels on that. Well, opposite 60 degrees is the square root of 3, but it's going to have to be negative because it's going down. And adjacent to it is a 1, and then the hypotenuse is a 2. And if we want cotangent, that's what you get when you flip tangent, which is opposite over adjacent. So we need adjacent over opposite. And that will be 1 over negative square root of 3. But of course, we rationalize the denominator, and that will give us negative square roots of 3 over 3. Then we switch gears and we go into radians. And number 9 says the sine of negative 5 pi over 4. So we have to go in a clockwise rotation, and we realize that's -1 1/4 pi. That's our thinking step. And that means we've gone all the way across and 1/4 of the way. Well, 1/4 of pi, which is 180 degrees, is 45 degrees. So our little central angle there is 45 degrees. And we would put the numbers of 1, 1, and the square root of 2 on for the sides and the hypotenuse. And then we'd make sure that we make this one a -1 because that's going to the left. And now we need sine. And sine is opposite over hypotenuse. So that will be 1 over the square root of 2. We rationalize the denominator and we get the square root of 2 over 2. I'm just thinking about that one. When I graded it, there were not a lot of people that forgot the negatives on those. That was nice. All right, number 10, evaluate the trigonometric function of the given quadrantal angle. If the value is undefined, write undefined. So this one, yeah, it was non-calculator. You had to do a little math, and you can see here I wrote out what's 360 times 4, and it's 1440. So then you do the subtraction of 1,710 minus 1,440, and you get 270 degrees. So 270 degrees, you can make the quick drawing and realize that's down here at 0, -1. And we're supposed to find tangent, and tangent in coordinate geometry is y over x. So that would give us -1 over 0, but we can't divide by 0, so that's undefined. Some of you lost a point there because you said -1 over 0 is 0. No, it's not. You can't divide by 0. It's the 0 on the numerator, on the top of the fraction, that gives you a 0. It's fine if the 0 is on the top. It's not fine if it's on the bottom. Then it's undefined. All right, number 11. We've got our omega piece here. Cosine of omega if the tangent of omega is -8/3 and sine of omega is greater than 0. So the first thing you have to do is figure out what quadrants it's in. So I make my little drawing with my plus, 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 minus, 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 plus, and minus, plus, minus. And I need to go where tangent is negative, but sine is positive. So sine is positive in quadrants 1 and 2, but tangent is negative in quadrant 2. So that's where I need to draw my triangle. And if omega, which would be right here is the central angle, has a tangent of -8/3, that would mean that opposite is 8, adjacent is 3, and then we realize, well, it's a -3 because it'd have to go to the left. So on this one, there were a few people that started to forget the negative when they were doing this one. So now we need the cosine, and cosine is adjacent over hypotenuse, which is -3 over the square root of 73 after we've used the Pythagorean theorem to get our hypotenuse, and we rationalize the denominator. Number 12, whenever you see these big numbers, you should be thinking back to what we talked about in class, which is it's all about the period. If you can divide for cosine what they're adding to it by 2 pi, that means because it's even, it's going to bring you back to exactly where you started. And where we started was pi over 6. 2,924 pi is definitely evenly divisible by 2 pi because it's an even number. So what we're really asking for is the cosine of pi over 6. Pi over 6, 180 degrees divided by 6 is 30 degrees. So you set up your 30, 60, 90 triangle and you figure out what the cosine is. Adjacent over hypotenuse, square root of 3 over 2. Number 13, this one says find the value of the unique real number theta between 0 and 2 pi. And some of you I don't think read the instructions because you were trying to give me stuff that was in degrees. They're telling us this has to be in radians. So this is another one of those little puzzles where we know that cosine is negative and sine is negative. So we have to go through, these are awfully faded, plus, 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 minus, 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 plus, and minus, plus, minus. And we need both sine and cosine to be negative, and that's only going to happen in third quadrant. So we draw our triangle and our reference angle down here in third quadrant, and cosine is adjacent over hypotenuse, so we put the 1 and the 2 down, and then we realize, well, those are special for a 30, 60, 90 triangle, so this other one has to be the square root of 3. But This has to be a -1 because it's going to the left. And now we want to tell them what angle would give us that. Well, the square root of 3 is across from this angle, which would make that a 60-degree angle. But it said between 0 and 2 pi, so what I have to do is think, all right, to get there, I'd have to go 1 pi, and then 60 degrees is pi over 3 more. So I'd have my 1 pi plus pi over 3. Well, common denominator would be 3 pi over 3 plus pi over 3, which would give us 4 pi over 3. All right, let me erase this. And I believe this is the last one on the non-calculator part. Yes, it is. All right, so find the reference angle for the angle below. And what we have here is 11/12 pi, which again, that's written the way we're supposed to think about it. We would never write an answer that way because we know historically that's supposed to look like that, 11 pi over 12. But often computers have a hard time doing that, so you'll see it written as 11/12 pi. I think this test had it both ways actually. Every once in a while they'd switch back and forth. But as I talked about in class, we know that we're supposed to have this as 11 pi over 12. So 11/12 pi is how we think of it because we want to think, well, I just went 11/12 of the way. So for my reference angle theta down here, how much is left? And that would be 1/12 of pi. But I have to write it as these are supposed to be written, which would be pi over 12. So again, it's that history piece of trigonometry that requires us to think a little bit more about how we write our answers and make sure that we are keeping that historical nature of trigonometry. All right, show all work. Convert the angle to degrees, minutes, and seconds. You had a calculator for this part. So what you had to do was think, well, I already know it's 249 degrees, but I have this 0.86 that I need in minutes. So you take the 0.86 times 60, and that gives you 51.6. So now you have 249 degrees, 51 minutes, and you need to figure out how many seconds. So you'll have to take the 0.6 times 60 to figure out how many seconds that would be, and that's 36. I don't remember anybody getting that one wrong. If somebody did, it was something goofy, like he just wrote down one of the numbers wrong or something. Oh, yep, we did have one person. Yeah, it took my memory a while to flip through all the pages. So just be careful with that. Make sure that you're going slow and getting what you need. We had more than enough time for this test since we took it over 2 days. Number 2 says convert from degrees to radians, and we've got 324 degrees. So you have to multiply that by pi over 180 degrees, and then you just do some reducing, and you get 9 pi over 5. Again, you're going to lose points if you write that. That's not how we write them. That's how we think of them when we're going to draw them. But that is not how we write our radians. All right, number 3, convert the radian measure to degree measure. 23 pi over 6, and so with this one we've got our 23 pi over 6, but we have to multiply it by the reciprocal of what we used in number 2, which is 180 degrees over pi. And the pi's cancel out, and you were allowed to use a calculator for this, so maybe you didn't even do the reducing that I have up there, and you get 690 degrees. But the label is important because degrees get our little bubble. Anything else is considered radians. All right, number 4. 4 and 5, there are a couple of people that struggled with this, which was kind of a surprise because it's different numbers, but it's the exact same problems we had in the review packets. So use the arc length formula and the given information to find the indicated quantity. And the arc length formula is S equals R theta, but theta must be in radians. So you have to take your 48 degrees and you multiply that by pi over 180 degrees and simplify that down so that you have your theta value of 4 pi over 15. And then we know that S is 16, we're looking for R, and we have our little 4 pi over 15. So we can multiply by the reciprocal, 15 over 4 pi, both sides of this equation. And I took 2 answers. The perfect answer, 60 over pi centimeters. And if you did happen to put that in the calculator, as long as you did our 3 decimal places, you know, that's what we're always doing, rounding to 3 decimal places in pre-calculus, then you get the 19.099 centimeters. Number 5, the minute hand of a clock is 5 inches long. What distance does its tip move in 27 minutes? Well, that's 27 out of 60, which you can do a little reducing on there by 3 to 9/20ths. But 9/20ths of what? Of an entire circle. And if I'm going to use my arc length formula, I need this in radians. So 9/20ths of 2 pi, because that's an entire circle. So that would give us, if we do a little reducing, a little canceling, cross-canceling here on this, that'll give us 9 pi over 10. And that would be our theta value. And the radius is going to be the minute hand, because that's in the middle and it's swinging out, which makes it the radius. So we'll have to take 5 times 9 pi over 10. Again, there was an exact answer for this one. You could put 9 pi over 2 inches. If you did go ahead and put it in the calculator, you needed to round to the 3 decimal places, 14.137 inches. Number 16, this is the unit analysis problem. And if you did not show your fractions and how you were canceling out the labels, you got absolutely no points for this, because unit analysis and dimensional analysis are a must at this point. So the radius of a car wheel is 12 inches. I start thinking, what does that tell me? That tells me that 1 revolution, because circumference equals 2 pi r, will be 24 pi inches. How many revolutions per minute tells me that needs to be my label when I get done. When the car is traveling 55 miles per hour, so here's my 55 miles per hour. The other 3 fractions that you see there are conversions so that we can make our way to revolutions per minute. So I already have revolutions in my label. I don't have to mess with that, but I definitely have to figure out how to get my inches, miles, and hours, to work out the way that it's supposed to. So I have to use 5,280 feet in 1 mile to get these miles to cancel out. I have to use 12 inches in a foot to get the feet to cancel out. And then I have to use hours per minute to make sure that that's going to cancel out. So there's my inches canceling away as well. And that will give us revolutions per minute. So like I said, you have to show this type of fraction work when we have unit analysis or dimensional analysis. You don't just punch it into the calculator and put an answer down. You're not going to get points for that. Number 7 says find the exact values of the indicated trigonometric functions. Write fractions in lowest terms. I did like what I saw was that everybody was showing steps all the time on these, and that's what you have to do, because remember, that's where all the points come from. So find the exact values of the indicated trigonometric functions, write fractions in lowest terms, and it says the secant of A and the cotangent of A, and we realize we're going to need the other side length. So we use the Pythagorean theorem to get the other side length, and it comes out nicely to 30. And now we need secant. So we remember that secant is what you get when you flip cosine. So it's going to be hypotenuse over adjacent. And this is the angle we're supposed to focus on, because they said angle A. So 34 over 16, which can of course be reduced to 17/8. And then we need cotangent, which is adjacent over opposite. So 16 over 30, which of course reduces to 8/15. This year I didn't have a lot of people that forgot to reduce. I think there were maybe 3 out of the 2 classes that forgot to reduce. We have to put them in simplest terms. Number 8 says solve the right triangle for all missing sides and angles to the nearest tenth. And on this one, oh, that's awfully hard to see. Again, some of these copied through really, really faded. So let me grab my copy here. And there's our little B. And C equals, this is A up here. And then they told us that angle B is 35.2 degrees. Right there. So we've got some stuff we have to find here. And what we need to do is use the given information for that. So we look down below and we see, aha, C is 14. We've got our angle B, and that's 35.2, and away we go. So if we know the 35.2, well, one of the first things we do is we take 90 degrees and we'd subtract the measure that we have for angle B to get angle A. Or we'd remember that every triangle has 180 degrees and do our subtraction. But either way we do that, the measure of angle A is going to be 54.8 degrees. Now, we should not use that to do any of the math, because if we made a mistake on that, well, then we're going to have mistakes upon mistakes. So instead, what we do is we think, all right, what do I need? What do I still have to find? And I went after A first, and if I'm using my 35.2, then that's my adjacent side. And I'm given the hypotenuse. So adjacent and hypotenuse would be cosine. So I'd use the cosine of 35.2 degrees equals A over 14, multiply both sides by 14. 14 times the cosine of 35.2 equals A. Then, if I need B, which I do, I'll start differently because this is going to be opposite. And I still want to use the hypotenuse because I know that. And opposite and hypotenuse is sine. So that one would be the sine of 35.2 degrees equals B over 14, multiply both sides by 14. So I have to see these equations. If when I went through your work, there were just answers, no points. The points come from the steps that you have to complete in order to get these problems correct. And then there were some people, every time that you round incorrectly on a problem, you lose 1/4 of a point on those. So you have to read those instructions. This was round to the nearest 10th. So our side length A is 11.4, our side length B is 8.1, and then of course we need the label of degrees on the measure of angle A is 54.8 degrees. And the box showed us it was 90, so we got all of that in there. All right, next up. Number 9, a word problem, but kind of not because you did already have the drawing. You just had to figure out how everything went together. So to measure the width of a river, a surveyor starts at point A on one bank and walks 73 feet down the river to point B. So there's our 73 feet right there. He then measures the angle ABC to be 24 degrees, 31 minutes, 12 seconds. Now, that is the first thing you have to deal with. You have to convert that. And so it's 24 plus 31 over 60 plus 12 over 3,600. Some of you had a 60 on the bottom of that last one for seconds, and that's not right. There are 3,600 seconds in a degree. So that's 24.52 degrees. And we have this angle right here. This is our theta, and this is opposite, and this is adjacent. And the trig function, when you think SOHCAHTOA that uses that, is tangent. So the tangent of 24.52 degrees equals x over 73. Multiply both sides by 73, and you've got it, except it said to the nearest foot. So you did have to do a little rounding there at the end. Number 10 says a 34-foot ladder So there's our little ladder. A 34-foot ladder is leaning against the side of a building. If the ladder makes an angle of 25 degrees and 55 minutes with the side of the building, well, I already know I have to figure out then what is that in terms of degrees. So it's 25 plus 55 over 60, which doesn't work out so swell. And we can't use decimals and rounding early on in a problem. So we really need to leave that as 311 twelfths degrees if we're going to be able to punch this into the calculator easily. And what we are looking for is how far it is from the base. So what we have is our angle, and opposite is x, and we know that the ladder is 34 feet, and that's hypotenuse. And the trig function using SOHCAHTOA that would do that would be sine. So the sine of 311 twelfths degrees equals x over 34. Multiply both sides by 34. Look back and see, did it say I'm supposed to round? No, it didn't, so I better go 3 decimal places. Some of you wrote down 14.86, and I gave it to you this time. But to really see that you knew we needed to go 3 decimal places, you need to put that 0 on there, because that shows you were following directions right up to the letter, and you had your 3 decimal places. Now, the extra credit problem shouldn't have been a major issue for everybody, because we did these, but you know, we had that long break in there too. You guys had 5 days off in a row, and I think that really messed with you quite a bit, because we talked about how if we have 251 pi over 7, we'd have to divide that by 2 pi to figure out how many full rotations this was. And it was going to be let's see, 17 times 2 pi, so 17 rotations, full rotations with a little bit left over there. So you have to take 17 times 2 pi to figure out that smallest coterminal angle, the one between 0 and 2 pi, which is the one we really want to use. And this was, in fact, let me rewrite that part too. So we had 251 pi over 7, and we need 17 times 2 pi. But we're going to need a common denominator to make that work. And our denominator here is 7, so that's where we get to this point. And again, kind of hard to read here. We've got the 251 pi over 7 minus 238 pi over 7. And you just do your subtraction and you get 13 pi over 7. But on the retakes, we don't do extra credit. It's just kind of nice that you would get to see all of these being worked out correctly. So, like I said, I think the 5-day break really hurt some of you. I also think that some of you have not been doing the homework every day, at least maybe when you were distance learning, you weren't necessarily getting it in every day, and you are hurting yourself by doing that. You really are, especially as we're learning brand new material now as we go deeper into the Chapter 4 trig material. You need to learn a little bit every day. It's important. Otherwise, we'd all just sit here all day. I mean, I'd love to teach nothing but the trig all day, every day, but you can't sit here for 5 hours, 6 hours and digest all that math. Your brain can't handle it, so we have to break it up. So make sure you're doing a little bit each day, and that also helps because if you're having difficulties, you can ask. You know that you need help because you're lost in something. So don't be afraid to ask for help as you go through this as well. So reminder, you've watched this video, you took really careful notes on everything that you did there. You go back in your notes, you highlight the problems that were similar to the ones that we had on the test, and you redo very carefully the blue and green packets, which are in the black folder so that you don't need to actually have another paper copy to do that. And once you have all those things, you want to go on a video and hold it up and say, here's the notes I took when I watched the practice test, and show me those. And then here you can see that I've highlighted in my notes problems that are similar. And then here are my review packets again, when I worked through them. Because we usually don't have time in class for you to do that. If there is time in class, hey, show me all that stuff in class, but you'll probably have to do it with the video. So make the video, get it to me no later than March 10th at 2:45. And hopefully, if you're wanting the retake, you'll meet that deadline of March 11th at 1:45. That's everything.